This is just an open discussion session on autonomous driving. So let me first talk a little bit about the logistics of what we're thinking of in terms of taking the Scenic project forward. So what we're really trying to do is, Scenic as an open source project has existed already for about 5 years, right? And we've been informally engaging with lots of people. But we feel the time has come to make things a little bit more systematic as the community around Scenic is growing. The decision making around the project needs to be done in a more systematic way than just a small group of us meeting in an ad hoc fashion and deciding what to implement, how to implement, what features are more important than others, and things like that. So that's partly why we've got funding from the National Science Foundation to support the Scenic open source project, right, and grow the community similar to other big open source projects. And as part of that, we are planning to organize working groups, formal working groups in Scenic on various topics. So some of these will be application focused. So there will be a working group on autonomous driving just because it's been one of our major application domains and just in terms of uptake by the community. And so that's what this is really, this meeting is about. It's basically about starting that conversation. We have some of our working group members whom we've already recruited who could not make this particular meeting today, but they'll be joining in future meetings online. Okay, and so that's sort of some context here. There'll be another working group on robotics and other domains, and there'll be a third working group on extended reality, and then there'll be a working group on Scenic infrastructure and language and so forth. Okay, so those are all the various working groups that we have planned. All right, so for autonomous driving, following up from yesterday's night's discussion, right? We talked about various sorts of use cases that people can think of and new that we can use Scenic for, as well as ideas for features that Scenic doesn't yet have that you would love to have. But I want to ask that question again here, specifically in the context of autonomous car and autonomous driving. Are there any particular use cases or features that you would like to prioritize? Any thoughts, any ideas there? The one thing I wanted to do here was we bring up a slide on which I can study. One more thing. All right, so I have a blank screen. And I can okay. So let me summarize some of the things that came up yesterday. If anybody want to make a suggestion first? Yeah,
I can reiterate what I said yesterday.
Okay.
I may like to give more context. Being able to basically upload a context into the simulator, starting the physics with a specific, from specific point onwards.
Yes.
I think that's also key for more scalable and more interesting analysis that we can do. Because like starting from the beginning of a scenario and then just rolling out the whole thing. It's just really good.
So let me repeat it for those online. I think that the suggestion made last night was, and this is something that we've had an ask for before, is being able to save the context of Scenic and the simulator and then resume from that or start a new simulation from that at some point. I think this is a great suggestion. Definitely something that we should have, but it's more of a Scenic infrastructure. It's applicable to all application domains, right? So what I'm asking for here in the session is something specific for autonomous driving or autonomous racing, right? In that general domain for ground vehicles.
I think that's something that we're planning on working on, which is that right now the driving domain in Scenic is still in 2D. So a big thing we're planning to, it's on our radar, is getting all of that in 3D so you can get 3D mesh information and like have just all that 3D information when you're using it. And, I mean, that's not as applicable to driving as the robotics or anything like that, but it has come up in certain areas, like overpasses, where it's undefined, in Scenic right now, if you have a car on an overpass and a car on the road below it. So that's something that we're planning on looking at.
Okay, so say that again. So
updating the driving domain to have 3D map information.
Okay. Yeah. Oh yeah, right. I think in general support for situating a scenario in an appropriate map, I think is an important missing feature in Scenic because we are restricted in terms of whatever limited maps we have. Okay. That's a really important. Okay. Other suggestions? So there were some notes that I made this morning during the session. And actually, this also came up in the break outside. So another suggestion is coverage metrics, right? So computing coverage metrics that are specific to autonomous driving. And part of this is also, if you think about coverage metrics, there's kind of two dimensions to that. So one is in terms of the scenarios, right? The database of scenarios. So you like to specify one Scenic scenario and then compute coverage of a falsifier or some other simulation-based verification testing tool with respect to that. But then there's also the question of, have you written enough interesting scenarios? And how do you measure that notion of coverage? I think it's also an open research question, but I think it's also a very important practical question. Right? So part of that is we want to create a database of scenarios in Scenic as a portable format. And while I've actually been on committees where people have talked about this in the context of autonomous vehicle safety, there's been a lot of talk and very little movement on this. Unfortunately, there are no good open scenarios beyond those that are just specified in English, like the OAS Voyage ones, but nothing in a programmatic format that is being made public. There are some alleged scenario databases that are behind paywalls. And you have to get a subscription and then you'll have access to that. So that's not really helping the community. So we'd like to create that database of scenarios in Scenic and then make it available to everyone. Okay. And the second aspect of coverage is metrics, but also properties. Right. And this is something that actually Kanchan started working on. Actually, we're talking with Locke about this. To take the prior work that she did on rule books and then basically build a big rule book that covers all the different properties. And it could be specialized for different locations also, right? Like in Pittsburgh, everybody does the Pittsburgh left. or not everybody, but a significant chunk of them. And so you would, the left turn rules is slightly different, right? Priority wise than in other places. So that's another thing you want to do, like create essentially a community rule book and then make it available to everyone.
I have a question. I'm just curious about that. So, probably like more like people who are coming from more of the like AI side of the CS will say, well, this is just like rule based. It kind of feels like similar to like rule based AI, trying to capture every single possibility with like a list of rules. Like, what's the
So the rule book stuff is just writing properties, whether they are Boolean or quantitative, right? So you have a set of properties, and then the rule book imposes a pre-order over them, right? And then what Kaichun talked about this morning is even that can be dynamic, state dependent, right? Scenarios, I think, is more what I think your comment applies to, which is people will say, okay, you wrote these 100 scenarios in Scenic, but what if something else happens? So the answer to that, I think, is twofold, right? So one answer to that is that at least by writing down the scenarios, each Scenic scenario, in theory, if you assume that it uses like true real value variables and so on, is capturing an infinite number of concrete scenarios. And then you have a finite number of those probabilistic scenarios, and that captures your assumptions. So that's your operational design domain, right? And then you want to be able to generate monitors, etc., that will tell you whether you're in ODD or outside ODD. That's one answer. The second answer is that having a database of Scenic scenarios, I think, is in some ways slightly better than having a database of just raw data, which is what they have right now.
I'd also say maybe like what Karim is doing, like from native language with Scenic.
Sure.
It's also maybe argument.
Yeah, I had 3 slides on Karim's work that I didn't have time to present this morning that I'm happy to show now. But I don't want to take time from discussion. I don't want to make it again another mini lecture. So we can talk about that later. But I think you raise a good question, which is a good point here, which is so there has to be an argument here about why the adequacy of these scenarios, like why are they sufficient? And then the second thing that you mentioned here was a flow from natural language to Scenic, or other kinds of data, right? And I think in my group, we have some initial work on this, but it's still a very hard problem. But ultimately, that's what one has to do, because it's hard to simply manually create scenarios, right? Yep.
Let's sign out for the staffing language data.
Yes.
Have you tried doing that or have you tried doing anything at all?
But they have implemented. I can show you results.
Okay. Yeah. My Cruz is doing it, like active doing that for a similar thing.
Okay.
So
You're doing from what to what?
like natural human language to a ROS API, of course.
ROS API.
So it's similar.
Okay. Well, I mean, we can talk more offline after I'll present. I just have a 2-slide summary of what we did.
Okay.
And there's a paper.
That might be helpful.
Do you have a? It can be.
Maybe defining some distance or similarity metric between scenes or scenarios.
Yeah, good point. So that metric between Scenic programs, right? I mean, ultimately, this is
Verified this in a way, I guess.
Explain what you mean by that.
I guess verified does it for samples, not Scenic.
For samples.
Yeah.
Yes. So for samples, we can do that actually. For simulation trajectories, there are many proposals for computing distances between traces or trajectories, right? So trajectories are simply a time series trace, finite. So any simulation trajectory is finite length. So it's like a giant vector.
Yes.
And you can compute distances between vectors. But using standard distance metrics, but people have come up with specialized distance metrics also for traces. And we actually use some of them in the AAA autonomous vehicle sim to real case study that I talked about this morning, where what we wanted to compare was how was the simulated trajectory in the GSVL simulator? How did that compare with the real trajectory of the pedestrian and the autonomous vehicle that we measured through GPS information, right? And so we actually had those two trajectories and we could compute a measure. And momentarily, there were two metrics that, so the one, there's something called DTW, dynamic time warping metric, which is just a pretty standard one for time series data. And there is something called the Sporocode metric, which is a more specialized metric that is defined for traces of systems, so dynamical systems. And we used both of those in the paper to quantify the distance and to try to explain where they differ, like what happened in the simulator versus in the real world. So one thing that happened in the simulator was that the simulator actually did not model the z direction, the vertical direction. So this assumed it was all flat. Whereas the actual road had a slight uphill climb when the car makes the right turn onto the right before the pedestrian crossing. Okay. And so what was happening was on the real road, the car was kind of it was going a little bit to the left as it made the turn, so a bit of a drift. Whereas in the simulator, it was doing a perfect right turn. And we saw that in the distance metric, and there's an explanation for that. Right. So things like that. But I guess so similarity metrics exist for individual traces. A Scenic program is a distribution over all of those, right? And so there are many ways you can extend that, right? But this is an infinite set of possible traces, and so you have to figure out how you want to do this. You can take the infimum or the supremum or other kinds of aggregate measures. So I think basically the research is not settled on what makes sense. Number one. Also, you could also say, I'm going to just compare two distributions, right? And again, it's more complicated for it's dynamic scenic, but for static scenic, you can actually use standard ways of comparing two distributions that exist, right? So that's one thing to do, right? Any other suggestions?
I've been working with some Purdue folks on this idea of a network traffic level driving domain.
Yes, right.
And so that would be interesting because we'd have to, the city doesn't really support that level of cars. It would probably be like a higher level of abstraction to represent like the flows of vehicles.
Right.
What we're doing right now. And it'd be really cool to extend that into sort of a co-simulation.
Right. I heard about this. So you're working on an interface between Scenic and Sumo plus.
I think it's Metzar Sim right now, but
what's Sim?
Metzar Sim. It's their in-house simulator. But
how do you spell that?
Metzar Sim. What's up? No, that's a different one. We're talking about
It's not small.
No,
Let me ask you.
Yeah, it's Mets, METSR Sim.
Oh, yeah.
But it's similar to Sumo. And so if you have a network domain, it could also be an interface to Sumo, and that's also potentially on that domain. But then you really need to have a co-simulation across with the two domains working in tandem. And there'd be some really interesting questions as to like how to sort of represent a unified sort of viewpoint for both of those, how not to impact performance, because you might want to have that finding control over Carla, for example, that's our sim. And so how to represent the two different levels of control abstraction. The one is like high level routes, and the other is actual visual controls. And I think this could tie into coverage because we could make an argument, I mean, not really coverage, but sort of bolstering our claim that the tests we're running are valid because we could sort of use this network level domain and actually sort of when we're simulating accurate traffic with that are maybe wouldn't count it.
Uh-huh. Yeah. That sounds. I think the general thing that I want to take away. I think the specific co-simulation of network level simulator with agent level simulator, I think is a great project. And you're already working on it, right? So for the short term, I think there's a longer term question of the co-simulation with multiple simulators, or even cross-domain simulation, right? So the idea with cross-domain simulation is something that another group that's interested in using Scenic came to us with. So they are interested in simulating. They have access to a proprietary simulator that does both ground vehicles and air vehicles, and so they want to be able to define like multi-vehicle domain. So right now we have the driving domain with its objects and its behaviors and actions and all that. We don't have anything else, but we have other simulators like AirSim and so on, which have a different set. And what if we wanted to mix the two, right? And now the question here is, I guess we were talking during the break about this, that you could define like an air domain and a driving domain, and as long as the world model in the sense of the set of objects and don't intersect, then maybe you could just import both and write behaviors over both of them. But I mean, I think this is something that we have not yet thought. We have not yet worked out, right? So that's sort of the.
I think this one is even a little more complicated because the domains are starting the same.
With different time scales and different.
Different levels of abstraction.
It's a good point.
Yeah.
So let me just write this down. Just put it in quotes. Something like sumo.
It's called Maths R. METS.
METS.
It's METS dash R.
METS dash R. So this is just in different levels of abstraction. There's also, I guess, this other thing that is multi-domain, which is really, I think, something even I think Edison in theory supports. Right?
Yeah.
Okay. Any suggestions from those online? Oh, just have Lee. Okay. Anything from your group, Lee?
We haven't started the project that uses Scenic, so we're not sure what we will need in the future now.
Okay. All right. Well, that's kind of the halfway point. Maybe what I'll do is stay in.
Sorry, I'm taking notes so I can put them in the same folder.
Okay, that's good. What I'm thinking is I will switch to the slides on natural language for Scenic. I'm thinking a little bit about that. Literally just have 2 slides on this. So, right. So this is the idea is what I just said, which is go from natural language to a Scenic representation, and so basically this is work that has been led by my student Karim and Marufi, and the system is called Scenic NL. It's version 1 was done in March, April. And a more polished paper will be appearing at this new conference on language models. Okay, so what's going on here? Imagine you take something like a DMV crash report or a autonomous vehicle incident report, right? It's all written in English. Actually, it's more structured than that. You have a form and you have different fields in the form, and you can have structured English in the sense of having different types of information. And so what we like to do is go from this to a Scenic program. But of course, Scenic is a DSL, which is in terms of the actual amount of data on which LLMs have been trained is something that is very, very, very underrepresented, if at all represented in the data set of these things. So even though Scenic is Pythonic, if you just ask for something to generate Scenic, it produces nonsensical stuff. All right, so what we do is a bunch of different techniques, and I don't have time to go into all of them here. But of course, I'd encourage you to read the paper. But the idea is to do at a high level a few different things. So one is this compositional prompting strategies. What that means is we're going to build up the Scenic program in segments. And Scenic, as you've seen from the syntax, it lends itself to doing that. So you have a section Scenic program, which is basically boilerplate, import the driving model, import a bunch of other libraries, map, and so on. So that's initial segment. Then there is some portion which may correspond to different parameters, like the speeds at which things were traveling, and so on. Then there are behaviors that are defined. Then there's like the initial spatial setup. What objects are there, where they're positioned, what the associated behavior functions are, and so on. So there's different parts of the Scenic program, and the idea is to kind of develop prompting strategies for each one separately, and then construct this overall Scenic program from that. The other thing is to use the standard tricks that people in code generation from LLMs or just using LLMs for any kind of generation have. So RAG is one. So retrieval augmented generation is one that is pretty popular. And the idea here is that we already have a database of Scenic programs. It's actually not large. Our database for this paper was, I think, 30-something programs, so pretty small database. But the idea is you take the embedding of this particular description, you query it against a database, you pull out the Scenic program that is similar, and use that in your prompt, right, as examples. Then there are two other things that are being done. One is called compiler feedback, and the other is execution feedback. So compiler feedback is what you think it is, right? You run the Scenic compiler, you may get a bunch of errors, and then you are feeding that back to the LLM and asking it to fix specific things. Execution feedback is more complex. The idea here is that you're actually running the simulator, right? So once you get a program that compiles, you running the simulator, it generates the trace, and then you get some information from that and feed that back. So that part, I think, is probably the most experimental and least robust part of this pipeline. But let me show you an example of what we're able to do with that. Goes up here. Good. So look at the part at the top. So the thing, the scenario description. This is what we got from the DMP report. So I'll just read it for you. It says a Cruz autonomous vehicle operating in autonomous mode is traveling eastbound on Place Street at intersection with Kearney when the Cruz AV slowed down. The driver of the Cruz AV disengaged from autonomous mode, and shortly thereafter, a bicyclist proceeding straight made contact with the right rear fender of the Cruz AV, damaging its fender. The bicyclist left the scene without exchanging information. There were no injuries. Police were not called. Okay, the kind of the narrative part of the report. What you see here on the left is the generated scenic code. So sorry, there's no syntax highlighting there, and your mouse is not showing up on the screen. But so you will see here up it says there's the map defined, which is town 01, and it's using Carla. And then it defines a bunch of parameters, right? So what's the model of the ego vehicle, the speed, it's at constants, and then it has the behaviors, and then it is setting up the geometry of the intersection where this happened, and ego agent and the bicycle agent with their behaviors. Okay. So let's just see what happens in this particular. Again, maybe it's frozen again. That. There we go. PowerPoint doesn't want me to play this. Anyway, so but if you want to see, maybe we should just go and see the recording of the CDPR tutorial. But what happens is that so it does actually come up with a replay in Parla that broadly replicates this scenario. And so, well, first of all, the Scenic program passes the compiler syntactically correct, and we were able to get over 90% syntactic correctness. Actually, if I can just. There we go. Thanks. Okay, so. There we go. So the bicyclist comes in, hits the fender. It's actually not the right rear fender, it's somewhere in the middle. But the bicyclist does leave the scene. Okay. Partly that's because the bicyclist is just following the lane. So the default behavior of the bicyclist is actually consistent with it. They didn't actually do anything special in terms of regulating that. Okay. But broadly speaking, there are aspects of it that are semantically correct. But it's not at the intersection either, right? So it's just on the segment of the road. So it's not in the middle of the intersection, which is what the narrative says. So there are some semantic issues still with what our pipeline generates, but at least it produces things that is enough of a scaffolding that you can then start to work with. sorry for all the issues with PowerPoint.
Is this an area that you feel like people outside of the university can contribute to? And if so, how?
So I think the most important way in which people can contribute right now is through data, being able to provide us with data that we can use to improve the model with, right? And this goes back to the point about the number of scenarios in Scenic is fairly small, right? So if we want to improve this and do some kind of fine tuning, then we need a larger data set and a more diverse data set. Right? So I think that's probably the number one thing right now. The other thing I should say is that we haven't really done a lot of things with different models. So this particular result is with probably the GPT-4. And I think we have experimented with a couple of models, but done nothing really super serious in terms of understanding and looking at models specific to code generation versus others. So I think there's more to be done in terms of many people in that regard as well.
There were no ground truth Scenic scenarios, right? I'm like pretty like didn't sit down and write the ground truth.
Except for the ones in the RAG. So we had those scenarios. We had the English narratives, and then we had the Scenic code for that.
For all of them, or just a small number?
This is good question. I don't know if.
I feel like maybe that can be a good like community effort or like
Yes,
or like the
I agree.
RLHF side of things.
Yes.
Can be a good community effort.
Is it possible to fine tune like model just for like not general purpose large language model, but language model just for general program like code about. So I think it's
That's right. Yeah, exactly. Yeah, that's the thing I was mentioning, that we have not really tried taking a language model that is specifically fine-tuned for code generation, or maybe just Python code generation in Python, and then try to fine-tune that. That would be a interesting. There's another group at UPenn that also tried to do a similar project where they did a LLM-based approach to generating Scenic, but they were just doing static Scenic, and they got some interesting results as well. So that's I don't know if we published the work at a conference, but it's on archive. Right. All right, so maybe we are maybe 10 minutes from the end of the session, so it's perhaps a little late in case you wanted to switch to the other session, but I want to give people that chance as well. But more importantly, are there other ideas or other points that you'd like to bring up and discuss? Yes.
I was thinking about like scenario synthesis. So, for example, in our dynamic group work, we a scenario is given with its corresponding group, and we try to sample from the parameter space of this scenario to find some counterexamples. And what if we start from some like general rules? For example, we want to generate some scenarios that a vehicle has a collision with a pedestrian. And starting from this rule, we generate some scenarios that violates this rule in maybe different situations, different weather conditions.
Yeah. So you want to synthesize a Scenic scenario from a safety specification.
Yes.
Right? Or to produce a particular outcome.
Yeah.
taking notes.
Yeah.
Use all my notes. Then on Zoom recording. Thank you. I'll do this one.
I have another small scale thing that we wanted to look at, which is improving the sort of built-in agent behaviors for scenic vehicles. So something like the intelligent driver model, like reasonable like lane changing, just so that because our current stuff like call lane behavior doesn't have a lot of
Correct? Yeah. That makes a lot of sense. Actually, this is something that somebody there's a group in Finland that's interested in implementing this. So there's a professor I think I forget his last name, but he was visiting Berkeley, and this is something he has done. He's more on the human computer interaction side of things, but he did some past work in trying to validate some of these models of interaction of pedestrians with vehicles and things like that. And so he's been very interested in Scenic, and so it was actually like, well, maybe we should implement IDM. Yeah. So I think that this should be done. Are there any efforts here or in the projects that you're involved?
I mean, it's something we're talking about with this tracer grant that we're on.
Oh yeah.
Specifically because there was this one paper where they learned the distribution is over like human drivers for the parameters of the IDM.
Yeah.
A really strong argument for this is realistic traffic.
Yeah.
So we're looking to sort of augment the counterexample.
Yeah. This sounds like something that we ought to just go and do in the short term, right? Yeah. So let me just implement it in the driving domain.
Yeah.
Yes.
While we're talking about LLMs, you could possibly use LLMs like a sampler for verify, but not like finding specific variables or anything. But let's say you have a scenic scenario. Just make the LLM add some specifiers to it. Basically, maybe this may be based on some verbal constraint you give it to, like maybe you cannot exactly define how to, define the A you want in the scenario. Maybe you can train it in a way that the LLM will do that for you, or figure it out. And, maybe the loss function could be how well it satisfies its own figured out, like, constraints.
So you're saying use the LLM to guide the search.
Yes.
Okay. But what would be the input that you're providing the LLM?
What I'm saying is, so I think while we're trying to sample with verify, we were giving some constraints that we want to maximize or minimize.
Right.
Maybe a verbal description of a constraint, for example, or just the constraint.
Yeah.
And we will check how well it does that by just adding some actual code to the file.
I see.
Yeah.
So the LLM is a way of translating essentially auto formalization of requirements.
Yes, actually. Like extracting rules, but the other way.
That's right.
Yeah.
Actually, I mean, come to think of that, and maybe there's a group that's done this. You could think about taking something like the California DMV handbook or, Indiana Department of Motor Vehicles or whatever it is, and you feed it to an LLM and see if you can extract a bunch of rules out of that.
And I would say Marcel's Alstar LLM paper is kind of doing that, right? It's just the requirements are just represented as automata. And like that paper attempts to learn automata, even examples using LLM.
But you're saying you can replace the automata part of that with something else.
Something.
Yeah. I mean, I think this is so my proposal would be to actually generate a rule book from that, right? Because there are implicit priorities and things like that mentioned in the text. I mean, it's not that easy, obviously. We want to be able to first extract the rules and then extract the priorities between them if they exist. So that would be an interesting project, actually. And
Also, maybe like how does like foreign language professors feel like using LLMs for synthesis instead? There's no way to prove anything. So like, are people comfortable with this kind of research?
So
the community.
I cannot answer for the community. I can tell you a variety. I think having tools for auto formalization is in general a good thing, because that's the biggest obstacle to using forming methods. Just who's going to write the formal specification, and so and even if there are people who write the formal specification, they will immediately they could make mistakes, and they do. Right, it's been documented in many industrial case studies. So I think it's good to have a tool like that, but you have to then supervise it. So, but in general, checking should be easier than generating, right? And so for that reason, a student or whoever's going through this still needs to have taken a formal methods class to understand what the output is and whether it's correct. But you can also use tools, right? So you can check for consistency among specifications, and you can use that. You can go through solvers. So that is
So then the argument is taking this cheaper than creating. So
that's right. Yeah, and you're still using formal methods tools in the places where they are applicable, right? I mean, formal methods tools cannot be used from natural language, but the reality is that most requirements are in natural language, or they're actually in some multimodal informal format, right? So they are in different kinds of natural language documents with mistakes, like typos and stuff with them. They have in Excel spreadsheets. It's like a mix of data. They have some databases, right? And it's like test suite. It's like usually the requirements are given in a very multimodal way. Now you have to take all that data and then turn that into a formal specification. And it's always been a hard thing. So actually, on balance, I think it's good to have stuff like LLMs that can turn that into a formal description. And once it's in a formal description, then you can analyze it, you can check it, you can do a lot of stuff with it. Right.
Has there been any thought on integrating the physics engine inside Scenic and how with that?
Directly implementing a physics engine, like a native physics engine in Scenic.
Or I mean, ask the user to give the kind of the equations or of some sort instead of using black box simulator.
Yeah. So. Right. So the question is, can you actually have a white box model, like a differential equation model in Scenic, right? And I think the short answer is yes, because you can integrate arbitrary Python code into Scenic, right? So you can use SciPy, and I've done this with Verify myself. I've written like a system of ODEs, run a simulation. Actually, ODEs where the parameters there's no randomness, but they are line ranges. Right. And so then I can ask, is there a valuation of parameters that leads to some outcome? And you can use Verify to do this. And just creating the system of ODEs using SciPy. So you can do the same thing in Scenic, I think, right? And it's certainly possible.